In January 2018, an amateur astronomer named Scott Tilley was scanning the sky from his home in British Columbia. He was not sitting inside a NASA control center. He did not have access to a billion-dollar telescope. His equipment included a homemade satellite detection system and a coil of copper wire mounted on his roof. That night, his receiver detected an unusually strong radio signal coming from an object orbiting Earth. At first, it appeared to be just another satellite, but when Tilley searched its identification number, he discovered something astonishing. The signal appeared to be coming from Image, a NASA spacecraft that had been declared dead after more than 12 years of silence. Somehow, a satellite that the world had given up on was transmitting again. On March 25, 2000, NASA launched a satellite designed to visualize the invisible. Named the Imager for Magnetopause to Aurora Global Exploration, Image, this machine was built to map Earth's magnetosphere. The magnetosphere acts as our planet's magnetic shield, a massive defensive bubble blocking the constant barrage of solar storms and highly charged particles streaming from the sun. While this shield is essential to protecting life on our world, it is completely invisible to human eyes. Before this mission, scientists had to study the magnetic bubble by sending single probes to take isolated local measurements in space. It was like trying to understand global weather patterns by looking at a single backyard thermometer. Image changed the scientific approach by taking full, wide-angle pictures of the entire system at once, showing the global structure instead of tiny, disconnected points. Using specialized ultraviolet cameras and plasma instruments, the spacecraft photographed the intense glow of auroras and mapped the flow of space weather as solar wind battered our outer defenses. For nearly 6 years, the satellite worked successfully, beaming back thousands of these global views. This data gave researchers a clear look at the active, constant connection between the Earth and the Sun. On December 18, 2005, the routine operations of the Image mission came to a sudden halt. As the satellite passed over the North Pole, controllers on Earth expected a standard transmission of data. Instead, they received nothing. Silence filled the control room. Engineers suspected a failure in the power system, specifically a component called the battery charge controller. In plain terms, a glitch likely locked the system, preventing the battery from maintaining enough voltage to power the radio. Power was the obvious suspect. There was still one hope for survival. In early 2007, a long solar eclipse would cast the satellite into complete darkness. NASA scientists believed this deep shadow would drain the battery completely, forcing the onboard computer to perform a hard reboot once it emerged back into the sunlight. But as Image sailed out of the shadow, the silence remained. The reboot had failed. Later that year, NASA officially declared the mission over. Failed was the conclusion. Over the next decade, the spacecraft drifted as a ghost. Antennas that once tracked it were decommissioned, operating systems changed, and the original team members retired or moved on. Yet, in the quiet of orbit, the dead machine kept circling, until a signal would suddenly appear more than 12 years later. On January 20th, 2018, at 1:39 a.m., a routine overnight S-band radio scan began running in Roberts Creek, British Columbia. The man operating the gear was Scott Tilley, a methodical electrical technologist who spent his spare time tracking classified military satellites from his home. The next afternoon, Tilley sat down to review the recorded data. Amidst the cosmic static, a single sharp signal stood out at 2,275.905 megahertz. It displayed a perfect J-shaped Doppler curve. Just as the siren of a passing ambulance shifts in pitch as it speeds by, the frequency of this signal rose and fell, proving the transmitter was in a rapid, highly elliptical orbit. Searching the public satellite catalog to match the trajectory, his analysis led him to a specific designation, object number 26,113. The database identified this as Image. Doubt immediately set in. If a NASA spacecraft was broadcasting this loudly, why hadn't he or anyone else noticed it earlier? By digging into the signal structure, he found his answer. What he had previously dismissed as a faint random hit was merely a weak harmonic. The main primary transmission was actually vastly stronger. When Tilley pulled up the official NASA documents, he found the mission described entirely in the past tense. The implication was stunning. The forgotten spacecraft had apparently rebooted on its own and was screaming into the void. Tilley knew a lone amateur's word wouldn't easily sway a space agency. He was, after all, just some guy in a basement with a piece of copper wire on his roof. To build a case, he first published his findings on his blog, Riddles in the Sky, and the CSAT-L mailing list, inviting the global tracking community to verify his data. Within days, an observer in the UK picked up the exact same signal. Boldly, Tilley emailed James Birch, the original principal investigator of the IMAGE mission. Birch did not dismiss the claim. Instead, he replied almost instantly, recognizing the orbital data and immediately alerting Richard Burley, the mission director at NASA's Goddard Space Flight Center. The news spread like wildfire through NASA Goddard, former mission engineers, and the Johns Hopkins Applied Physics Laboratory. Professional ground stations across the United States sprang to action. Heavy antennas in Maryland, California, New Mexico, and Virginia began swinging toward the sky. One by one, these independent sites locked onto the transmission. They confirmed the signal's exact S-band frequency, its orbital path, and its transmission characteristics. The data from across the continent matched perfectly. Yet to officially declare a dead satellite resurrected, NASA needed more than matching trajectories. They needed to pull a specific, undeniable digital fingerprint from the raw data. IMAGE relied on 1990s-era systems that no longer existed in usable form. To decode the signal, engineers had to retrieve original mission files stored on fragile 4mm magnetic tapes. Because modern computers could not read the legacy format, finding a safe tape reader became a major hurdle. If the tape snapped, the data would be lost forever. NASA ultimately borrowed a vintage backup reader from the SOHO mission. Even then, the engineering team had to emulate obsolete Unix operating systems on modern Linux platforms and write custom scripts to convert the proprietary binary files. At the Johns Hopkins Applied Physics Laboratory, engineers spent hours tuning ground antennas to the exact frequency and testing communication settings to match the decade-old telemetry protocols. On January 30th, the telemetry locked. Real engineering data began flowing. At exactly 3:21 p.m., the lead telemetry analyst opened the first decoded file. He scanned the raw packet headers, searching for the specific numeric tag used to route the spacecraft's data to the correct mission database. 166. It was IMAGE. Subscribe to follow more untold stories of space exploration. The decoded telemetry painted a baffling picture. Inside the drifting Explorer, the battery was fully charged at 28 volts, and temperatures remained near original mission values. Against all odds, the hardware was in near-perfect health. Engineers suspect the satellite had been transmitting silently for years before Tilley's scan. A spontaneous electrical event, perhaps a charge redistribution in the power system, likely triggered the unexpected reboot. Yet NASA never established a definitive cause. The awakening was temporary. Soon the signal began to fade and drift unpredictably. Although teams read basic housekeeping data, the communication never stabilized enough to restore command. IMAGE's brief return remains an unsolved mystery. An extraordinary, fleeting whisper from a machine that survived in the dark. Today, thousands of silent satellites drift through orbit, yet IMAGE proves that what we abandon is never truly lost, and that the next great discovery might start in a backyard. The cosmos remains full of sleeping giants waiting for us to listen. Subscribe for more incredible space mysteries.